Alright, so in the last video we talked about conjectures, which were just an educated guess. And I mentioned that there might be some things that we want to be careful about because even though they're educated, they are a guess. So to highlight what I was talking about, let's go ahead and look at an example. So let's say we were given the set of numbers 1, 2, 4, and then we are asked to continue the sequence. So that means find the next couple of terms in there. So at first you might be tempted to say that to get from 1 to 2, I multiply by 2, and to get from 2 to 4, I also multiply by 2. So then to get to the next number, I would multiply by 2, and I would get 8. Multiply by 2 again, I would get 16, multiply by 2 again, and I would get 32. So, in this case, you have looked at a pattern and made the conjecture that we're multiplying by 2 every time, so our next numbers in the sequence would be 8, 16, and 32. So there is actually another way I can continue this sequence, and that is by adding consecutive numbers. So what I mean by that is adding 1, then adding 2, then adding 3, and so on. So to get from 1 to 2, I can add 1. To get from 2 to 4, I can add 2. And so to get from 4 to my next term, I would add 3. And so then 4 plus 3 is going to give me 7. So then to get from 7 to my next term, I could add 4. Then 7 plus 4 is going to give me 11. Then to get from 11 to my next term, I could add 5, and so then my final term would be 11 plus 5, which would give me 16. So I can also continue this pattern by adding consecutive numbers 1, 2, 3, 4, 5, and so on. So then in this case, my conjecture, instead of multiply by 2, would be to add consecutive integers to continue the pattern. So we just looked at an example where there were two plausible conjectures. So the key to figuring out whether or not your conjecture is going to be true or not is to see if you can find a counterexample. And a counterexample is going to be any example you can find that will show that what you're saying is not true. So let's go ahead and look at an example, and let's consider the statement, you can connect any 3 points to form a triangle. So in your head you might be thinking, well, if I draw any 3 points, of course, I can totally draw a triangle through that. Let's draw 3 more points. Yeah, I can draw a triangle. Okay, but our strategy that we just talked about was to see if we can find a counterexample. So, what if all 3 points were collinear? Then when I connect them, I draw a straight line, and this is not a triangle, so this is a counterexample to show that our statement is not necessarily true. So let's go ahead and take a look at some problems involving counterexamples. So go ahead and find a counterexample for each of the following statements. Problem number 1, when you multiply a number by 2, the product is greater than the original number. So go ahead and pause the video, take time to find a counterexample to this statement. So you are looking for a case where when you multiply a number by 2, the product is not greater than the original number. You're looking to find a counterexample to my statement. So now that you've taken time to work this on your own, we'll go over it together. So there are lots of examples where this might work, where when we multiply a number by 2, the product is in fact greater than the original number. So one of those cases might be if we multiply 4 by 2, then we get 8, and in fact 8 is greater than 4, which was our original number. So this is an example to support this claim. But let's look at a counterexample. And so keep in mind that your counterexample might be different than mine, but yours will have the same basic idea. Let's say we take the number -4 and we multiply it by 2, then we get -8. -8 is actually less than -4. And so this is a counterexample where we find that even though we multiplied this number by 2, the product, which is -8, is not greater than the original number. And so we found a counterexample to our statement. Let's go ahead and take a look at the next problem. So you're trying to find a counterexample to this statement. The statement is, if the name of a month starts with the letter J, it is a summer month. So you are going to try to find a counterexample to this statement. Go ahead and pause the video, take your time to think about it, and see if you can find a counterexample to this statement. So now that you've taken time to work on this on your own, let's go over it together. So our statement was, if the name of a month starts with the letter J, it is a summer month. So some examples to support this might be June or July. These are both summer months and they both begin with the letter J. So these are examples to support this statement. However, we are looking for counterexamples. So a counterexample for this statement is the month of January. It starts with the letter J, but it is a winter month. And so we have found a counterexample to prove this statement false.